So here you got a big trapezoid B, and a little trapezoid A, and you're trying to find x, y, and z. So in order to do that, you need to use proportions. So you first do x over 10 is equal to 15 over 24, 24 being the base. Okay, so then you multiply 10 and 15, and you get 150. And then you divide that by 24, and you get x to equal 6.25. Okay. And then to find y, you do the same thing. So you go y over 10 is equal to 16 over 24. You multiply the 2, you get 160. Divide that by 24, and you get y to equal 6.66, repeating. And then to find z, you do z over 10 is equal to 12 over 24, or 1/2. And so then z would be equal to 5.
Alright, to solve our problem, we kept in mind two basic concepts. First was proportions, and second was similar polygons. Now, I won't go over proportions because I assume you already know what they are. Well, for two polygons to be similar, two conditions must be met. First, corresponding angles should be congruent, and second, corresponding sides are in proportion. In our problem, we had two trapezoids that were in proportion, trapezoid A and trapezoid B. So we used ratios because when two polygons are similar, they are in proportion together. So we used proportions to solve for x, y, and z. The trapezoid problem can be used in the real world as well. For example, many basic bridges use trapezoids as their trusses, and most of them are shaped trapezoidal as well. Now, let's imagine a scenario where an architect is trying to build such bridge. First, he must create a blueprint, and that blueprint must be in proportion to the actual size of the bridge. So, he must use our problem to solve for each length of the big bridge. So that's how our problem can be applied in the real world.